Okay, we're going to do a little bit of categorical logic exercises. I assume that you've looked at the Prezi and you followed along with that, but it's a good idea for this sort of thing just to do it, kind of see the process, right? See how I go through the steps. So then maybe you'll be able to do it quickly and easily. And there really isn't that much to this, right? Remember, there are just the four types of statements that you have to learn how to categorize using these circles, right? There's the universal affirmative right here, universal negative. Both of these are universal negative. And then you have particular affirmative and particular negative. And each of those has a special way of being symbolized using circles. Yeah, so hopefully you've got that as background knowledge for that. If not, go back to the Prezi and just look at that chart that shows how to symbolize each of those four. And there are only four ways of symbolizing. That's all you need. Because then all you're going to do is use the rules to symbolize both of the premises with the three circles. Okay, and then you'll see if the conclusion just shows up all on its own, right? So here we go. Let's do this. What's our first step? Well, you know you're always going to start with one of these three circle deals, right? There's going to be three circles. When you're learning how to do each of the individual statements, there's just two circles because each individual statement is only going to include two different categories. But an argument is going to include three categories. You see that? We've got the C, we've got the O, and we've got the T. Right, so we want three different circles for the three different groups. Yeah? Okay, so then your first step is to look first, what is the middle term? Right, the middle term is what both of the premises have in common. Right? Which of the subjects or predicates are the same? Well, O, right? This one has C, but this one doesn't have C. This one has T, but this one doesn't have T. But they both have O. So that's your first step. Identify the middle term and put that in the middle, right there, right? This is what both of the premises have in common. So make your middle top circle the middle term. Then you just have C and T to write down, and for that you just look at the conclusion, right? Oh, it's on the left, it's the subject term in the conclusion, then put it right there. The predicate term in the conclusion, you put it right here, right? So this is how you figure out how to label each of the three circles, right? You've got three different categories, C, O, and T, three different groups of things. We want to symbolize those with the three circles. How do we do that? Well, make the middle one the middle term. That's what they both have in common. And the bottom, you just want to follow what the conclusion says. So now we've got each of our groups labeled, each of our categories labeled. Now all we have to do is use our knowledge of those four different kinds of statements and plug them into this format. Right? So all C are O. That is saying that if you're inside of the C member, you're also if you're a member of the C group, you're also a member of the O group. Right? So this is saying about the C group and the O group, you can just completely ignore the T group. Right? Just ignore it. Right? This is saying that if you're a member of C at all, then you've got to be somewhere in the O circle as well. And of course, the only spot that you can hang out is right here if you're going to be a C. So everything outside of the O circle is going to be blacked out, right? Remember, this means there's nothing there. It looks a little weird on the whiteboard, but this should be total blackness. I'll do it this way this once, and then from here on out, I'm just gonna kind of fill it out because this is too time consuming and it looks kind of bad. Okay, just gonna do that for this one. Okay, so now you see that there's nothing in the C circle. If you are a member of C, then you're in O. Basically, that's what we're saying. All C are O, right? There's no C's that are not O's, so there's nothing outside of the O circle. And so we can even color over the T circle because this part is outside of the O circle. We know there's nothing there. Right? And so if you just ignore this, this is just exactly what a universal affirmative looks like. You've got all this part of the predicate term, the subject term, all blacked out except for what's inside of the predicate term right there. Right. So all we've done so far is plugged in this first premise. All CRO, this is how you do it. Now we want to say no ORT, a universal negative. So we look at the O circle and the T circle, and we realize, okay, no ORT, that means there's nothing in the overlap. There's no O's that are also in the T circles. There's no O's in the T circle. All members of O are outside of the T circle, basically. That's what we're saying. Okay? So there you go. Now we've symbolized both of the premises, and now we just look back, look at the whole thing, look at the whole structure, and check to see if it also says no CRT. Okay, well, let's look. Let's look at the overlap between C and T. That would be this whole area right here. It's completely blacked out. So it's true, no CRT. There's no members of the C group that are also members of the T group because that area is completely blacked out. And it's completely blacked out just by plugging in these two premises. So the fact that the conclusion is just there all on its own, just by plugging in the premises, that shows that it's valid, right? We've said this before, right? A valid argument is one in which it's impossible for the conclusion to be false and the premise is true. So here we've represented the premises as true, and sure enough, this part is filled in. If you try to erase that, you'd be messing with the premises, right? So it just makes sense. If both of these premises are true, then the conclusion must be true. And we can see that because just by plugging in the premises, the conclusion shows up all on its own. Okay, that's the first one. Let me get the other one ready. Okay, next one. No F are L, some L are not H, some F are H. Okay? So all we have to do is follow the same steps. First, we need to label the circles. They each need to be labeled appropriately according to their group. To keep it consistent, what we always do is find the middle term, what both of the premises have in common, and put it in the middle top circle. That's L. And then to figure out where the F and the H go, just look at the conclusion. F, H, F, H. Okay. Then we just follow the rule for how to diagram a universal negative. That's always going to be, you're going to black out any overlap between F and L. When you say that no F or L, you're saying that there's no overlap between those two groups. Right? No F or L, that means we're going to look at the overlap between the F and the L and black it out. Right? No members of, same problem. No members of the F group are also members of the L group. Right? Okay. Quick example, just so you can think of it less abstractly. Think, for example, we use this example, right? No one under 18 is a legal beer drinker, at least here in the United States, right? There's lots of members of the group, people under 18, and there's lots of members of the group, people who drink beer legally, but there's no overlap between the two. If you're a member of the group under 18, or under 21, I guess, then you're not a member of the group of people who drink alcohol or beer legally. Right? There's no overlap between those two. So if that's what you're imagining, imagine that this is people under 21 and this is legal beer drinkers. You're not going to find any of these members in this group right here. Right? That's what no FRL means. So that's why this overlap is just all blacked out. There's nothing in there. There may be F's and there may be L's, but there are no F's that are also L's. No F or L means all blacked out. Okay? Some L are not H. So that means there are some, at least, remember some means at least one. Right? There's at least one member of the L group who is not a member of the H group. So at least one, we signify that with a little X, and we're going to put the X outside of the H circle, but inside of the L circle. There's only one place to do that, right there. Right? This means there's at least one member of the L group, but that member is not part of the H group. You know, maybe there are some members that are in H. That's not what this is saying. It is just saying that there's at least one guy that's an L but is not an H. So okay, so now very simple, right? We've just plugged in both of the premises, and now we want to see, does this say that some F are H? Right? Again, if this is valid, then just by plugging in the premises, we would see the conclusion show up on its own in symbolic form right here. So some F, we're talking about the F circle, are H. Well, what would that look like? It would mean there's at least one member of F who's also a member of H. We just don't see that. That would look like this. Right? That would look like that one up here. It would be a little X to indicate that there's at least one member of the F group who's also the H group. But that didn't show up just by plugging in the premises. Right? It does say some L are not F. Right? That you could have drawn that conclusion. Right? You see that? Just by plugging in these two premises, you could conclude some L are not F, because there's an L right here, and it's not in the F group. But that's not what the conclusion says. The conclusion says some F are H, and that's just not there. Right? So these two do not logically entail the conclusion. So this is invalid. If it was valid, we would see the conclusion. If it was valid, we would see this show up all on its own after having simply plugged in the premises. Okay, so this one is invalid. Okay, it's a rather lopsided diagram. I think it'll still work. So this is a tricky one on purpose, because you'll see at first it seems as though we can't do it, but there's a trick to it. Okay, first things first, this part is easy. Middle term is Q, so they both have in common. And then the B and the Q, oops. There's a whole other problem to this, is I wrote Q instead of S. Okay, I need to fix that really quick. Sorry about that. I was almost going to start all over, but then I realized this sort of thing happens in class as well, and you probably pointed out gleefully. Okay, this is what I was supposed to say. Right. Okay, so all we're doing right now is this is the argument right here, correctly put, and now we're plugging it into the diagram. We got our middle term, and then to fill in the rest of the diagram, we just look to the conclusion, just like we did for the prior two ones, right? So the B is going to go on the left, and the S is going to go on the right. Okay. Okay, that's all fine and well. Okay, no problem there. The problem is when we try to plug in our first premise, some B are Q. Now remember, for that we take a little X and we put it in the overlap between B and Q. We want to say that there's at least one member of the B group who's also a member of the Q group. So we put it somewhere in this overlap. However, the premise does not tell us whether it's also in the S group or not. We don't know. That X might have to be put over here. It might be the case that that member also has to be a member of S. So right now, we don't know where to put it. Right? And if there was no solution to it, then we would have to write the X right on the middle, and we just have to stop, and we have to say, well, we can't evaluate this argument. However, there's a nice trick to it. Whenever you have two premises and one of them is a particular statement, save the particular statements for last. Always do the universal ones as well, whether it's a universal negative or a universal affirmative, because those will narrow down our choices most of the time, right? So here you see the first premise and you can't figure out where to put it, because again, you can't really decide where to put it. It could be here, it could be here. We just don't know, so we can't plug it in because we're making some sort of statement that the premise is not making. Right? So far we can't do anything. But if you follow that little trick and put a pin in the problematic one, always just do the particular statements last, do the universal ones first. That's going to solve your problem. Okay, so let's focus on this one. No Q or S. Now that's easy, right? We know that there's a Q group and an S group, and we're saying none of the members of Q are members of S. There's no overlap. So symbolize accordingly, right? We're saying there's nothing in the overlap between Q and S. Okay? So now that's gotten rid of our whole problem of ambiguity. We know that there's nothing in here, no members. There's nothing inside of Q and S. Right? That means there's no B's in there either. There's nothing in there. That's what we've said. That's what P2 means. That's what this premise means. There's no members of the group Q who are also members of the group S. So then once we've categorized that, or rather symbolized that, then we can go back to the particular and say some B are Q. Okay, the B circle, the Q circle, we're saying there's at least one member, little x, that is a member of both of these groups. Now it's easy. Now we can put it right here because this is all blacked out. Once something's blacked out, you can't put anything in there. All right. So that's much easier. You see that? Whereas if you try to do this one first, you wouldn't be able to decide where to put it. So always do the universal statements first. Even if you see a particular first in the argument, just look at both of the premises, and if there's a universal in there, do the universal first always. That's going to save you a lot of problems later on. Okay? So now we just still have to evaluate the argument. Does this say that there are some B that are not S? Is there a member of the B group that's not inside the S group? And the answer is yes, right there. There's at least one B that's not an S. So we just plugged in premise 1 and premise 2. This is the diagram that we get. That diagram also shows the conclusion automatically. It says that some B are not S. Some members of the B group are not members of the S group. So this one is valid. Okay, so there the main takeaway is whenever you get one of these categorical logic arguments and you have to visually represent it using the Venn diagram, always go for the universal statements first and save the particulars for last. Okay, here we go. Let's try to get the beginning part going faster. Hopefully it's just very clear to you what the first steps are. Middle term, middle circle, look at the conclusion, P and F. Okay. We're starting with universal this time. That's great. That makes it easier, right? Because if this had been the first premise, you would want to do the universal one anyway, right? Because I just told you, avoid doing the particulars first if you can. Do the universals first. In this case, the universal is already first, so that's fine. Easy. No P or Q. Well, that means there's no members of the P circle that are members of the Q circle. If you look at your chart, you'll know how to do this, but you can also just do it by thinking about it, right? Once you understand that the shading blackout technique means there's nothing there ever, there's no members that are in both sides of the category, that are in both categories, then you know you can just symbolize it like that. No P or Q looks like that. Right. Everything in the overlap is blacked out because there aren't any members of P that are also members of Q. Of course, that means there's no members of Q that are also members of P. That means the same thing. There's just nothing in the overlap there. Okay, now we want to say some Q are F. Some Q are F. Well, that means there's at least one member in here. There's at least one X that we can put in there, but it's also a member of the F circle. And there's only one spot to put that, which is right here. Right? Everyone see that? If this hadn't been blacked out, we'd have a little bit of problem. We wouldn't know where to put it, here or here. But luckily, this is already decided for us. This is the only place where you can be a member of Q and also a member of F. So now we've represented both of the premises. Do we see the conclusion? The conclusion says some P are F. That means there would have to be an X in the P circle. Some P, at least one P. It would have to be an X in the P circle and also in the F circle. So it would have to be right here. It's not there. Right. So this conclusion does not follow logically from the premises. The whole argument is invalid. Okay. Here we go. Next one. Let's do this fast. N, middle term, middle circle. Look at the conclusion, S and H. First step. Okay, that part's always easy. Particular. If there were a universal, we'd skip the particular and go for the universal first. But in this case, we don't have that option, and that's sometimes going to happen. So what do? Well, first, just let's look and see if there's anything we can do. Some S are not M. Okay, well, that means there's some member of the S circle that's outside of the M circle. So somewhere in the S circle, I have to put a little X to indicate at least one member, aka some, and it's outside of the M circle. Unfortunately, there are two different places where I could do that, and I don't know which it is. The premise does not tell us. So we can't really symbolize that one, right? So whenever that happens, at first see if you can do the other one and see if that helps. Sometimes it might, even if it's not a universal, though I'm not sure about that. At the very least, you at least try to see what happens. And for now, we have to skip this one and see if we can do this one, see if that's any better. Some M are not H. Well, it's the exact same kind of statement. It's the same kind of diagram. It means that we have to put an X somewhere in the M circle that's not in the H circle. So somewhere out here, but we don't know if it's here or here. Right? So we're in the exact same position as we were before. So if you really want to go ahead and symbolize it, this is what you would do. Since we don't really know where to put it for either one of them, what you would do for each of them is you would say some S are not M. Okay, so I know that there's an S outside of the M circle. I don't know if it's here or here, so I'll just put it right on the line to indicate our lack of knowledge. We just don't know where it goes. Okay? And then you can say some M are not H. Some M. There's some members of the M circle that are not in the H circle. Okay. Well, then we put, you don't know where to put it, right? There's some here that are outside of this circle, so that means either here or here. We don't know where. So this is what we end up with. And whenever you have any categorical logic argument where you have to put it on the line like that, you just can't draw any valid inferences. So when this happens, you just have to say invalid. Okay? That's all there's to it. That's sometimes going to happen. I hope that's clear. Right? One of these cases where it fails because you can't even symbolize it. There's a lack of information for us to symbolize this correctly, and so we just can't draw any conclusions. So it's invalid just by default. Okay. Here we go. Middle term, Z, right there. Look to the conclusion, B and X. Okay. All B or Z. Well, everything that is in the B circle is also in the Z circle. The universal affirmative is symbolized like this. There's nothing in the B circle outside of the Z circle. There are no members of the group B outside of the Z group. If there's any B's at all, they'll be in here somewhere, right inside of the Z group. Yeah. No Z or X. Okay, that means there's no overlap between the two, between Z and X. There's nothing that's a member of both the Z group and the X group. So that gets blacked out as well. And this is what we're left with. I feel like, did we already do one with this form? If we did, it's okay. Now we just have to see, is it true, according to this diagram, does this diagram say that there's no B's that are X's? And we simply look at the overlap between B and X, and we realize there's nothing there. So yes, indeed, the conclusion is represented in the diagram automatically just by plugging in the premises. The conclusion showed up all on its own. So it's another valid argument. Some P are M, no P are J, therefore some M are not J. Is that valid or not? Let's check. Well, notice first we've got premise number one is a particular statement. Now remember the problem with particular statements. If you have an empty diagram, we won't know where to put it, right? So we're going to hold off on that one um, and look at the universal instead. I realize I just skipped over the first part. The middle term is P, right? P and P, and then we look at the conclusion, M and J. And so yeah, if we want to say some P are M, we'd have to put an X inside the P circle, also inside the M circle, but we don't know if to put it here or here, so we can't put it anywhere, or we put it right in the middle. But the universal might help us out to narrow it down. The universal here says no P or J. There's nothing in the P circle that's also in the J circle. There's nothing in the overlap, so we can cross all that out. All right, so now we've got that second premise represented in the diagram. Now let's go back to the particular and see if it's any easier. Some PRM, okay? There's at least one member in this group, at least one, we're going to put a little X somewhere in the P circle. That's also in the M group. Now there's only one place to put it. There's only overlap right here. All right. Okay, good. So now we are actually able to diagram it. If we had to put it in the middle, if we didn't know where, then the argument would just be invalid by default. In this case, it's not the case because we've got that universal blocking out this whole area, so we know we can only put it there. So now we simply look at the diagram to see, is the conclusion represented as well, automatically on its own, just by plugging in the premises as we just did? Well, some M are not J. That means there's an X, right? We're going to put an X somewhere in the M circle that's outside of the J circle. Do we see anything like that? Well, yes, we do right here. Right? There's at least one member of the M group that's not a J. Yeah? So these two premises together logically yield this conclusion. We can see it. Right? That's the cool thing about this. It's a visual representation of the fact that once you've got the premises, you also have the conclusion. That's how validity works. It's not logically possible to represent the premises without representing the conclusion as well. It just shows up on its own. Okay, so another valid one. Maybe a few more and then we'll be done. Okay, hopefully this is helping. Okay, next one. Middle term, B, and then Q and S right here. Yeah. Let's symbolize the universal affirmative. Has to do with the B and the Q circles, right? It says all B are Q, so there's nothing in the B circle outside of the Q circle. If you're a B at all, you will never live outside the Q circle because that's all blacked out. So this says all B are Q, right? So if you're in the B circle at all, you're somewhere in here. You're also in the Q circle. Yeah. I hope that symbolism is clear to you. It helps once you get it, why it's visualized this way. Right? It basically just means this is space to live. If you're a B, if you're a member of this category, you'd be right here somewhere. Right? We don't necessarily know where, but certainly not anywhere over here. So that's why we black it all out. Now we want to represent some B. Some members of the B group are not members of the S group. Some members of the B group are not members of the S group. So we put an X somewhere in the B circle. Some is going to be an X to indicate at least one. It's going to go in the B circle somewhere, but outside of the S circle. Well, there's only one spot for that, right here. Okay. Now we just look and see, does this also represent the conclusion? Do we see the sentence some Q or S show up here? Well, no, right? Because that would mean there would be an X somewhere in the overlap between Q and S, but there's nothing there. So the conclusion did not show up all on its own. If it did, it would look like this or like this. Right? It would have to be somewhere in the overlap to indicate that there's at least one member of Q that's also a member of S, but we don't find that. The only X we have is right here to indicate that some B's are not S. Right? We could conclude that there are some Q that are not S, right? So if it had said this, not, it makes all the difference in the world, this little word not. This would be valid, right? Because there's at least one member of the Q group outside of the S group. That would be valid. But since this is what the argument said, the argument is invalid because this conclusion did not show up automatically in the diagram after plugging in the premises. Invalid. Okay, last one. Hopefully this is just becoming easy, almost boring in how easy it is, hopefully. If not, if something is fundamentally unclear, please do contact me. Just shoot me an email or something like that. Hopefully we're, sticking to the very basics enough for you to be able to follow. Okay. There's probably a lot more complicated stuff that we would do if we're meeting face-to-face. But these are special circumstances, so I'm just giving you the distilled version, right? Not too many problematic ones, pretty straightforward ones for the most part. Okay, so let's do one more and see if you can follow along. And for all of these, it might be a good idea if you watch this all the way through just for the instruction part of it, that's fine. But then maybe rewind the whole thing and pause on an argument before I go through the steps and see if you can do it on your own, okay? I don't know how I'm going to test you on the actual Venn diagrams, but I will at the very least, in a quiz or a test or the final, whatever it may be, I will have a bunch of these kinds of arguments for you to test for validity, and I would expect you to do it with this method, even though I can't verify necessarily how you did it. At least I'd want you to use that method to optimize your chances of getting the right answer. So you should be learning this, right? You should be knowing how to do this on your own, and you will be tested on that. That will be a big part of your grades. You're supposed to learn how to do categorical logic, right? So do for sure test yourself, work with this until you get it. And one way that I'm saying that you could test yourself is to use this video, pause it every time before I go through the whole explanation, like right here. You pause it right here and see if you can do this on your own, and then you can check how you did it versus the way that I did it. Right? That's one way to test yourself. Okay. No V or G, no G or O, no V or O. Okay? These are all universal negatives. Right? So they're all going to involve blacking out the middle area, the overlap between two groups. Okay. Middle term, G and V and O. No V or G. Okay? That means there's nothing in the overlap. If you're a member of the V group, you are not a member of the G group. So this whole part gets blacked out. There's nothing there. No G or O, do the same thing. We black out the whole overlap between G and O. Some of that's already done, right? Okay, so this is what we end up with. Now we just look at it. The conclusion says no V or O. Does the argument say that? Does the diagram tell us that there's nothing, that there's no V's that are O? It does not. If it said no V or O, then all of this would be blacked out as well. Okay. So that makes this argument invalid. Okay. I hope that makes sense. Let me know. I'll do the same thing I did before. I'll open it up. This could be like a discussion post where you don't have to post anything, but you can. You can ask questions or something like that. Okay. Enjoy the rest of your day. Bye.